Hi, you guys. It is Miss Johnson. This is Honors Chemistry. We're talking about significant figures. Oh, look at Chewy. You love him. Choo choo choo. This is Unit 1, and this is technically Notes 2 and 3. So, why do we use significant figures? Because in my class, when we do calculations, no one knows how many decimal places to put. And when scientists and teachers and students all over the world have to do math problems, we need to make sure that we have a set of rules that gives us the same answer. And we're not really sure of anything in this world. But the numbers on the left side of our answer are the ones that we're most sure about. So for example, right? Like let's say that you're weighing something, right? And you get on the scale or you weigh this thing on the scale. That little decimal point, you might notice it changes. And sometimes the other numbers do too, but that number might change more frequently than you would expect. But the number to the far left rarely ever changes. It's the most significant. So when we count our rules for significant figures, we're always going to start counting going from left to right with the first non-zero number. And you can see I put a little squiggle under the 1, and I put a little squiggle under the 5 because that's where we're going to begin. Oh. Rule number 2, all non-zero numbers are always significant. I might have mixed these rules up in class, so maybe in your notes it's like rule number 3, but they're all the same. Okay, any number that isn't 0 is always significant. Ooh, rule number 3, zeros that come before or after a non-zero number are not significant unless there is a decimal in that number. So when there is a decimal, zeros that follow that non-zero number and the decimal are significant. And this is the rule that people hate, and it really trips you up the most. So here's lots of different little examples that you can look at. There's some with decimals and without. And if this is going too fast, just push pause. Don't worry. Number 4, zeros between non-zero numbers are significant. Right? And look, I highlighted them for you in this beautiful green. Oh, have you noticed that each time the little smiley faces are getting angrier or more confused? I thought that was funny. Okay, rule number 5. When we're looking at numbers written in scientific notation, they follow all the same rules, but we just don't include the base 10 or the exponent. Okay, so here's 2 examples. And I wrote which rule goes with each little number if you need to go back and check in this video. All right, so when we're multiplying and dividing, I love this. This is the easiest part. We just look for the smallest number of sig figs and we report in that number. So look at 543 compared to 0.051040. 3 significant figures are smaller than 5, so our answer has to be 3 significant figures. We report the smallest number of significant figures. Okay, well, let's look at a word problem, right? Don't worry about solving this, but in this word problem, I have 2 numbers, 89.99 and 5.6. 5.6 has 2 sig figs, so my answer must have 2 sig figs. It's the smaller of the 2. All right, now when we're adding and subtracting, we don't really care so much about sig figs, we care about decimal places. Okay, and this is kind of like a problem that we did in class. We're going to look at the fewest number of decimal places, and we're going to report that many decimal places. So you will always have to round. And I'm sorry, not sorry, because you're juniors and sophomores and seniors, so you know how to do that. Hey, don't give up. Okay? Chem is try. Bye, you guys. Have a great day.